Okay. How are you guys doing? Good. Okay? Good. Just some bureaucratic notes. I'll repost the solutions for the homework one. Hopefully today. I have the corrected homework one here to me, so at the end of the class you can come up. Before you start asking me or complaining about grades, I did not grade. None of the grader did. Most people, the graders have some final parts, so we can explain to you why you got the grade you got. Okay? But remember that if you did well, congratulations, this is going to count for your final grade. If you did poorly, it doesn't matter, because if the final is higher than what you got in the homework, the final takes the place of it. Okay, if you remember the rule of the game, 25% of the final grade is between the maximum of the homework one and the final. So if the final is bigger than the homework one, it's the final that takes the place. Don't worry in the sense that you should absolutely need to get a higher grade, but worry in the sense that you probably miss something, some understanding of what's going on so far in the class, and that's why that's such a good grade. But don't panic. I have off hours today from 4 to 6 in lunch, so you guys can come. I know there are some things in the forum that I haven't answered yet. I also have place. Hopefully by tomorrow I'll have the homework 2 posted on the website. The homework 2 will be for Monday, not the next one, the other one, the 29th. And then it's the last homework you guys have to do. It's probably going to cover all the way until tonight. Okay? Any questions? Yes. I know, final is the last day of class. It's the Wednesday of week 6. I think it's the 31st. It's 31st of July. Yes, right.
This is going to be a during report.
It's going to be another. Okay, having said that, let's move to the class. Hopefully last class we kind of closed what was the core of game theory, the results, and now we're going to do some application. There's a big chance, I'm pretty sure you all guys have taken intermediate or introduction to micro before. You have seen what is a market in perfect competition. I'm going to talk to you again about perfect competition. And then we're going to move to monopoly, and those are going to serve as benchmarks for the other results we're going to find. We're also going to see how is a market that is in a duopoly. And there are different ways of modeling a duopoly when there are only two firms there, and they arrive to strikingly different results. At least conceptually, this class is way easier than the previous one because we're not introducing new things. We're just going to see more different markets, take a first order conditions, find Nash equilibrium, and that's pretty much it. So this is supposed to be a little bit like any questions so far? Okay, without much further ado, let's go to the model of the perfect competition benchmark. So this is a little bit how the general model is going to be. Okay. I hope you guys have seen this before. If you haven't, just come to office hours or just ask questions now. It's okay. So there's a demand for homogeneous good. And this equation here is the demand that we have. And Q is the total quantity produced in the economy, and A or B are just positive parameters. There are many small firms, each with cost of producing C of Q. It's increasing and convex function. And they all take the price P as given. So they are so small, so this is not essentially a game. The price, the final price that they have there, the total quantity matters to the price, but they, since they are very small, they take this price as given and just maximize the profit. Okay? So, they want to maximize the profit, then they give to the profit the letter pi. So basically the problem becomes so they will choose the quantity that maximize the profit, and the profit is always the price times the quantity sold, which is the revenue, minus the cost. And this is something that if you do accounting, if you do business, quite often you get distracted by the fact that what is the objective of this firm? The objective is always to maximize profit. Graphically speaking, there's a quantity here, and as a function of the quantity, oh, this is the small q, I'm sorry, it's not a big q. I try to keep small letters for things that are related to the form, and big capitals for things that are related to the market. Okay? If it sometimes it doesn't get clear in some point, just let me know, and there's a good chance. So the firm takes the price as given, and they have a cost structure. Can anyone tell me, just by the graph, what is going to be the quantity that maximizes the profit? Come on, guys, I know that's easy. I was mean, because you still cannot see the quantity there just by looking there. Yeah, it's not this quantity here. This is the minimum, the minimized the cost. Actually, it should be average cost. And it's not actually this quantity here, right? We have to differentiate this function. To differentiate this function here, you just take your first order condition. Differentiate with respect to q, you get the p minus marginal cost has to be equal to 0. So the quantity that maximizes the profit is such that, this is marginal revenue. So we have to differentiate the cost function. When we differentiate the cost function, we get our marginal cost function. And the marginal cost is exactly the minimum. This is not the cost, this is the average cost. And the quantity that maximizes is Q star such that the price equals to the marginal cost. proofs, you're going to find, oh, the quantities of marginal revenue equals to the marginal cost. This is always true. Economists like to give names to every time they find first order conditions. And they give, oh, a different intuition. It's just differentiating a maximization point. That's all it is. But they like to give you MC equals to MR, marginal cost equals to marginal revenue. That's always the case. What happens, the peculiar issue about, or the peculiar aspect of perfect competition is that the marginal revenue is just equal to the price. If I go there and decide to produce one more unit, I'm so small that I'll be able to sell this unit, and also I'll have no impact on the price. This is true for perfect competition. It's not true for all the other models we have here. But it's always true the marginal revenue equals to marginal cost. That's just first order condition of the maximization. Now, just an example of cost function which is not equivalent to the one that is there in the board is the cost of Q is just equal to C times Q. My cost for is just an increasing function, a linear function of the cost we produced. If this is the case, the cost is just a linear function. It's just a linear function of the quantity produced. The marginal cost is just going to be equal to C. Is equal to C. And it has to be the case that in equilibrium, the idea behind imperfect competition, usually the story they were told in Econ 11 or in some micro, is that the price has to be equal to the cost. And it's kind of weird because there is no reason, those are exogenous parameters here, by the way. C is bigger than 0. There are exogenous parameters there, and they're only true by coincidence of life. The intuition that usually professors will give you is, oh, if this is not true, if price is bigger than the marginal cost, many firms will come in the market, or the firms will have incentives to produce infinity, or many firms will come in the market, such that the price will lower down. In the other way around, firms will get off the market. If the cost is bigger than the price, firms will get out of the market, and the price will rise until this point. Yes. Yes, the marginal revenue is the same for the price. This is not, it's a good point, because this is not going to be true in the next graph. The idea behind is if I produce one more, I can simply sell one more with the price that is there. Think about that I have a small soy farm. I have a small cherry farm. I'm really small there, I'm producing cherries in the vine. My cherries are just at the market of the cherries, which is $3.99 per pound. If I decide to produce one more pound of cherry, I'm not going to impact the price of cherry. So if I produce one more pound of cherry, I just get the price of the pound of cherry back. Marginal revenue equals to marginal cost. Perfect competition. No. The marginal revenue equals to the marginal cost. Understand? It's just the idea of marginalism of optimization. If I produce and sell one more unity, I will stop in the point where producing and selling one more unit yields me zero of extra profit. But still, the profit is very big here. The whole profit here, actually, it's right. So now let's check what is the total quantity here in this market. Well, if price equals C in equilibrium, we can use the demand function that so far we haven't used at all to solve, to see what is going to be the quantity produced. Oh. Okay, now just solve this equation. C is equal to A minus B times Q. So the total quantity produced in this market is A minus C divided by B. And this is the quantity of perfect competition. So every time that I find a result there, a quantity, I put this upper script there, which shows this is the specific quantity of this specific market. This is a nice benchmark. There's very few markets actually can be well approximated by perfect competition. No, but it still is true that the closer you are to the fundamentals or to the assumptions of the perfect competition model, the closest you'll be to the result. Those all parameters. This is the intercept of the demand curve. This is the marginal cost, and this is the sensibility. The elasticity. No, it's just the marginal impact of price, of quantity in price. PC stands for perfect competition. This is the price for perfect competition. Okay? Just because I'm going to have one for the quantity for perfect competition. I'm going to have one for monopoly and one for others. They are just the parameters of the exogenous parameters here and there. When I give you exercise, there are going to be numbers. A is going to be 100, A is going to be 2, 1/2, something like this. We can have different intuition for these parameters. For example, A is the intercept of the demand curve. Right? So it's the price such that the quantity is going to be equal to 0. B is how sensitive to an increase in price the demand is. If I increase the quantity a lot, how much lower the price has to be to sell those quantities. And C is the marginal cost. Let me give you a lexicon here of the factors. because it's a linear function, a linear demand function with a constant marginal cost function. I don't want you to get fixated in what does here mean. I'm just going to use this to compare to the results of monopoly. Because along the class, I'm going to keep the same demand function, the same structure, the same cost structure, but I'm going to change the market so we can compare those quantities. Okay. So let's change the monopoly. Who here has never seen monopoly before? Monopoly, like this problem of monopoly solved. No one raised the hand, I'm going to go faster. Oh. Okay. Okay, now I'm no longer in a competitive cherry market, but I'm the only one who produces cherries in California. I'm the cherry baron of California. And I control, and now everything else is the same. So everything is this. Yes. Second. Now everything else is the same. The demand is the same. I also have a cost Q. But in some sense, it's the extreme opposite of perfect competition. There are not many people producing cherries, just me, the cherry baron, and I have to maximize my profit. In some sense, this is the ideal world for if you are a businessman. Your dream is to run a monopoly. It's the maximum profit you can obtain from the market. Some people think erroneously that if you are the monopolist, you're going to make the price as high as possible. That's not the case. Because even if I own the monopoly of cherries, I still am constrained by the demand. The quantity and the price, they're a function of each other. They are related to each other. If I put basically, if I put the price of cherry really, really high, people are not going to eat cherry. Let's eat lychees or cranberries. Lychee is my favorite. And in Brazil, it's really great. It's also really rare cherries. They only come in Christmas time. Price, quantity, no cherries. So if I put the price of the cherries really, really high, very few people are going to buy cherries. My profit is not going to be so big. On the other hand, if I decide to sell a lot of cherries, the price I'll have to put a price really low, and my profit is not going to be so high. So this is an interesting problem. It's not trivial. Even if you're the monopoly, even if you're Apple, if you're the only one producing oil, you're still going to choose the price to maximize your profit, and the price is not necessarily arbitrarily high. Everything else in the problem is the same. Okay? So now, the only difference is that now I have to maximize. I'm also still choosing quantity. By the way, in this case here, I've chosen quantity and have price as a final product. I could have done the opposite. I could choose price and have quantity as a final output. So, I'm again maximizing the profit with respect to choosing quantity. And the profit still is price times the quantity that I choose. it was before. But now how does the problem change from this case from perfect competition to monopoly? Say it again? Yes, we no longer take the price as an exogenous parameter. Indeed, the price will depend on the quantity that we choose. So our price actually will be the whole demand curve. Well, we're the only ones selling cherries here in our farm. So we're going to take the demand curve as given. And that's going to be our constraint of price. So I'm going to plug here that the price is a function of the quantity that I'm doing. By the way, they're choosing small q and I have total of big Q. I think it should be obvious that in this case here, big Q equals to small q because we're in a monopoly. So the total quantity produced in the market equals the quantity that our product produces. So in this framework here, they're exchanged. Okay, let's follow the suggestion. So we are actually replacing this here, maximizing Q, and now we're replacing the demand curve here. A minus Q times Q. Okay, taking first order conditions of this problem here, differentiating, making it equal to 0, this is what you get. Again, we're going to have marginal revenue minus marginal cost is going to be equal to 0. As I said, it's just optimality. But now here, let's differentiate this guy here with respect to Q. We have A minus 2 Q minus Q. This is equal to 0. This implies A minus Q divided by H. Let's put a graph there to see what is going on. Okay, similar to what we had before. Yes. What? Oh, the B is this parameter here. This thing is it was before. Oh yeah. So now we have the same average cost. We have the same marginal cost. But now our demand function is different. We don't take Q as given. I show demand function is the market demand function. And now we have one more. It's supposed to go. Now we have one more line here, which is actually the marginal revenue. The marginal revenue here is this guy here. And as you can see, the marginal revenue also starts at A. But now, instead of going back, diminishing as in a rate of B for every Q that I produce more, it diminishes the rate of 2B for every Q. So actually the inclination here is half of the inclination of the demand. So, now can anyone point me in the graph, what is the quantity that maximizes profit? Yes, it's the same quantity. It's not the same quantity. It's a different quantity, but it's the same rule. Right? I'm sorry. Yes. Oh, yeah. Shut down. No, there was another. So the quantity here is such that marginal revenue equals to the marginal cost. Still the same rule. And the profit. And the price, well, we find the quantity that maximizes the profit. Is such that marginal revenue equals to marginal cost. So we decide to produce the quantity, and now the market is going to determine how much they're going to be willing to pay for that quantity. So the price is given here. So we choose the quantity, and the price is the one that the market is willing to pay. We could do the opposite problem. We could simply choose the price, and from the price back to see what is going to be our quantity to be produced, and the market will determine the quantity that they will buy for this, and I will have my profit there. We just had to do in this way because it's slightly simple. Well, in order to compare this with the total quantity that was produced in perfect competition, I'm going to impose that they have the same cost structure as before. Okay? Let's impose the same cost structure as before. Okay, the cost function is just a variable C, marginal C, and a fixed cost F. This implies that the marginal cost is equal to C. Now, what is the total quantity that's going to be produced? We have already solved for this. I'm just plugging what is implied here. The marginal cost is just, which implies the quantity of monopoly is equal to A minus C divided by 2. What happened if we compare the quantity of monopoly and the quantity of cherries that were sold in perfect competition? It's pretty obvious that if you compare this number here with this number here, the quantity of monopoly is way smaller than the quantity of perfect competition. You can also see what is the price, and then the quantity is A minus C divided by 2B. Price of monopoly. And since A has to be bigger than C, otherwise no one wants to produce anything, the price is bigger than the price in perfect competition. Yes, Kate.
Can you explain
Which stuff? This one here?
Yeah. So we just replace
Just replacing 5.
because Q star is Q.
Yes.
Sorry.
F is a fixed cost. It doesn't matter for the cost so far. This happens when you have a monopoly. You have a smaller price, a higher price, and a smaller quantity. Also higher profits. Indeed, the biggest profit that you can get is when you're a monopoly. You can choose to produce as much as you want, and you get a higher, and you can make a lot of profit. questions. There's also the thing that you can calculate how much the dead weight lost due to monopoly, how much the total society loses because of that. You probably have done this in Econ 1, and I don't want to spend time here. I don't spend time doing that because I want to get to the part of the things that have been doing in this class so far. And I got the game theory part. So far there was no game. We either had one single player in this market, one producer, and an infinite number of small consumers that don't matter in the case of the monopoly, or have perfect competition where everyone is really small, such that whatever one farm does, if I have a small cherry farm, if the other cherry farm decides to produce 10 more pounds of cherry, does not matter if my problem at all. It doesn't change the price of cherry. Whatever they do, they do. But now here we will be in a situation where we move to duopoly, when you have only two firms in the market. When you move to duopoly, we get back to the realm of game theory. Because now, what I do matters to what you do. And solving this problem is slightly more complicated. Well, there is an issue about how to model duopoly, which means the way that they're choosing, whether they're choosing prices or they're choosing quantities, they arrive to strikingly different results. We're going to do both of them, but both of them are classical results in economics. One of them is due to Bertrand, which was a French economist from the late of 19th century, and the other one is due to Cournot. In Bertrand, they choose the price, and in Cournot, they choose quantities. And the results are very different. to duopoly. There is one technique to find a Nash equilibrium, and I think it's useful sometimes. And some people even say use it as a definition of Nash equilibrium. That I haven't employed here so far very much. I kind of mentioned a little bit, but I haven't employed so far. So I would like to talk to you about it briefly, and I think it simplifies the problem of